So now we're going to take a look at problem number 6. On a TV quiz show, each contestant spins a wheel with 36 slots, one of which is gold. If the spin lands on the gold one, the contestant gets $50,000. If it lands on any other one, the contestant wins nothing. The host of the show wants to know the probability that 3 out of 100 contestants will win $50,000. So part A asks, is this binomial? And I've written the 5 criteria below so that we can go through and check them off. So the first one, there's a fixed number of tries. In looking at this, we're talking about exactly 100 contestants. So we're going to say, yes, this is a fixed number of trials, and in this case, n, the number of trials, is 100. The trials are independent. In this case, we're not pulling from a population. Each person is spinning this wheel on their own. We're going to assume it's random. So we don't have to worry about replacement or non-replacement because each person spins the wheel themselves. So the trials are independent. Can we identify success versus failure? In this case, I'm going to call success winning the 50,000. And I'm going to label it that way because the host wants to know the probability that 3 out of 100 will win. So that's why I'm calling that success. And then failure is not winning. Condition 4, the probability of success is constant for each trial. So everyone's spinning the same wheel. There's only one portion of the wheel that wins. So the probability of success for each trial is 1 out of 36 because it's divided into those 6 different slots. And then you're looking for the probability of r successes out of n trials. In this case, we're looking for the probability of 3 successes out of 100 trials. So we can say that it is binomial because it meets all 5 of our conditions. In part B, we want to know the probability actually now. Let's find it. So we had r is 3, n is 100, p was 1 out of 36. We'll have to figure out what that is so that we can also find our probability of failure, q, which is 1 minus 1 over 36, or we could call it, in this case, 35 out of 36. So there are a few ways to do this. You've practiced on your calculator using the formula. So the formula for, let's say, P of R is NCR times P to the R times Q to the N minus R. And you've done a lot of practice putting that into your calculator. If you were going to do it for this one, it would be P of 3 is 100 C3 1 over 36 cubed times 35 over 36 to the n minus r, so 100 minus 3 would be 97. And I can plug that in. 100 C3 times 1 divided by 36 to the third times 35 divided by 36 to the 97th. And that gives us a probability. I'm going to make sure to write down my calculator input as well as my answer in order to get full credit on the quiz. And this would give me about 22.5% that 3 out of 100 contestants will win the 50,000. I just want to show you one other way to do this on your calculator. And I'm going to do second vars. And then if I scroll to A, binom PDF, this is to find exact binomial probabilities. So I'm going to hit enter. We have 100 trials. Our probability of success is 1 out of 36. And we're looking for 3 successes. And I can hit enter. And notice how that enters it. If you have an older calculator, like Haley, if you're watching this, I know that yours probably will not pop up with the same screen that I have. But notice the order that it went in. It goes N, then P, and then R with the commas separated. So if you enter it that way, you should get the same result. I'm going to hit enter, and notice that I do get exactly the same answer as when I put it into my formula by hand. So if you want to use Binom PDF instead to find exact probability values, you're welcome to do that. Or if you feel more comfortable with the formula, that's fine too.